According to the most recent Eurostat data, road accidents involving pedestrians are still a main problem to tackle in European cities, representing a significant share of injuries and deaths on the road. Improving the citizens' safety at crossroads is of particular importance for various municipalities. The objective of this use case is to increase pedestrian crossing safety in a smart city by leveraging on the IoT and edge infrastructures realized in the EU Korea project Decenter. This approach focuses on equipping pedestrian crossings with IoT and edge computing devices able to monitor pedestrians that intend to cross the road. The objective of this use case is to use the support of AI algorithms and cloud edge orchestration to timely spot any potential dangers that might be putting pedestrian safety at risk and provide means for notification alerts. Our goal is to prove that our use case and the Decenter technology behind it can play an important role in ensuring safer crossroads in our future smart cities. This project demonstration use case is implemented and executed for the Municipality of Trento. The execution of this use case and the interactions with the Municipality of Trento enabled us to identify additional stakeholders that would benefit from the Decenter results, besides the citizens as main beneficiaries. These stakeholders are backend cloud providers, edge providers, IoT service providers, application developers, and smart city operators. The smart pedestrian crossing brings benefits to both pedestrians and drivers. In fact, pedestrians are alerted when a vehicle is approaching the crossing through light signals and acoustic buzzers. Similarly, light signals alert drivers when a pedestrian is crossing the street. The providers of back-end cloud services are used by smart cities to support advanced applications for their citizens. Relying on an infrastructure controlled with Decenter solutions can give them the additional advantage of extending the reach and the use of their assets without investing themselves in edge infrastructure. This is realized through vertical and horizontal handoff capabilities of Decenter, fostering easy interaction, integration and orchestration of resources between back-end cloud and the edge of the network. Such an improvement of resources availability can be achieved when there are service providers that might already have physical presence with hardware installations in a roadside cabinet close to the crossings. Roadside monitoring and interpretation through AI algorithms of CCTV camera feeds can be enhanced with additional data available from IoT devices deployed to monitor road conditions, environmental parameters and other measures that help assess potential dangerous conditions that increase the risk of accidents. Access to such additional data feeds is important to improve the quality of decision-making and can be a further opportunity to exploit the digital twin capabilities of the Decenter platform. The deployment of monitoring devices of different nature, such as cameras, microphones, IoT sensors, can foster the creation of new services. The talent of smart application developers can be exploited to improve existing services with better performant AI algorithms. Decenter makes it easy to replace containers for that purpose. Furthermore, the development of this use case enabled us to provide a visual dashboard that makes it easy for the smart city operators to keep an eye on how the deployed services are performing. Smart city operators can also set up decision rules for lights and buzzers. This use case demonstrates how the Decenter platform components and services can be used to build a distributed application composed by several duly orchestrated between the cloud and the edge microservices, able to exploit efficiently the infrastructure resources while taking into account the application performance requirements. In this demonstration, we showed how vehicles and pedestrians can be detected elaborating with AI algorithms that data stream coming from video and audio devices. Alert notification thresholds are sensitive to environmental conditions monitored with sensors that provide information about the weather conditions at the crossing in real time. Actuators are made of flashing lights and acoustics buzzer devices which are activated to alert the pedestrians when a potentially dangerous situation is detected. Despite the fact that improved safety is the main target as it can save lives, privacy preserving is also an important aspect when dealing with video or audio data collected in public places. The deployed Decenter platform and infrastructure has the ability to process privacy-sensitive data at the edge and dispose of it after notification alerts are fired, without the need to send any of such data to the cloud backend. Managing resources distributed across multiple architectural levels and physical locations within the infrastructure is not a trivial task. With Decenter's multi-tier platform, resources can be easily managed and orchestrated within the cloud-to-edge continuum and ensure adequate performance at the provided safety services. In this use case, it's important to be able to timely recognize as many vehicles as possible. It can be a problem if new objects are not recognized due to an inadequate or obsolete AI model. With Decenter, each application service instantiation can easily retrieve and install a new AI model from the repository. In a street crossing scenario, if a dangerous situation is detected, alerting a pedestrian must be done with as little latency as possible. If application services are distributed between edge and cloud, and network conditions change, network processing latency can cause an increased delay in detecting a potentially dangerous situation and warning pedestrians in time. With Decenter vertical orchestration capabilities and the contribution of the digital twin infrastructure, the system can react to adverse networking and competing issues, and move microservices accordingly, reducing overall application response time.